Hello everyone. This is lecture number 2 for the course Engineering Mechanics. The content of this session is resolution of forces and the numerical of resolution of force. That is, we are going to do certain problems on resolution of forces in this session. So let me take the first example. So the question is, resolve the forces F1, F2 and F3 as shown in figure. You can see there is a hook which is displayed on the screen, and then we can see the axis of reference, that is x-axis and then y-axis. Okay, so this is the x-axis and then this is the y-axis. There are three forces which are acting on this hook, that is F1, F2 and then F3. Okay, these three forces are acting on the hook there. The value of F1 is 600 Newton, the value of F2 is 500 Newton and the value of F3 is 800 Newton. And the dimensions of this particular hook is given over there. What is the width of the hook? It is 0.2 meter, and then that is from the reference axis to the center of this particular portion. This is 0.2, and then the vertical distance from x-axis to the center point, it is 0.1 meter. And then you can see there is a point B here, there is a point A. Okay, so what is the horizontal distance from the y-axis to point B? It is zero point 0.4. And then what is the vertical distance from x-axis to point B? It is zero point 0.3 meters. And then we can see F1 is making an angle of 35 degree with respect to horizontal, and then F2, the angle is not given but the slope is given. Similarly for F3, slope is not given and then angle is also not given. Based on the available dimensions here, we have to find out the angle made by F3, and then we have to solve the problem by resolving all these three forces into x component and then y component. Before proceeding with the problem, let me find out the angle made by each forces here. Okay, so F1 is making an angle of 30 degrees, 35 degrees, sorry. There is no problem with F1. Let me go for F2 here. F2 angle is not given but the slope is given. Okay, let me take the triangle here. Okay, so let me take this one as theta here. I'll take the same triangle, this triangle, and then I'll find out the angle theta here. Okay, so now in order to find out the theta, let me go for tan theta here. Tan theta is equal to opposite upon adjacent, that is 3 by 4. So we can find out the angle of theta is equals to tan inverse of 3 by 4 over there. Okay, this is 3 by 4. So you will get the answer for theta as 36.86 degrees. This is my theta with respect to F2. Coming to F3, we don't know the angle made by the force with respect to horizontal, and then we don't know the slope also. Now what we'll do, we'll just drop a perpendicular like this from this point to this point, and then again I'll draw a perpendicular to this point B. So here this makes a triangle here. We have to find out what is the angle made by the force B with respect to any reference axis. We know if the angle is made with respect to the vertical axis, what is the formula? If the angle is making an angle with respect to horizontal axis, what is the formula? We have discussed it in previous session. Now let me find the angle theta with respect to the given triangle over there. Okay, let me refer this point as O in triangle AOB. So which trigonometric function we can take here? Okay, so this is point 2. Okay, the entire distance is point 0.4. The half of this would be point 0.2. Okay, so because point 0.2 is here, total distance is point 0.4. So point 0.4 minus point 0.2, it will become point 2 only. Okay, so this distance is known to us. Now we have to find out what is the distance from A to point O. Okay, so from A to point O, it is point 0.1 plus point 0.3. So the total distance is point 0.4 here. So let me take again the angle as tan theta is equals to opposite, that is point 0.2 divided by point 0.4. Okay, so the angle is theta equal to tan inverse of 1 by 2. So you'll get the answer for theta as 26.56 degrees. Okay, so now we found out all the angles made by the force F1, F2 and F3. Okay, so before proceeding with the problem, let me prepare a table so that it will be easy for me to find out the forces, that is x component, y component of each forces there. Okay, so let me write here. So let me prepare a table with first column as force and second column as x component and the third column as y component. If we prepare a table like this, it will be very easy for us to calculate here. So let me write my first force as 600 Newton and the second force as 500 Newton and the third force as 800 Newton. Okay, these are my three forces here. So let me go for the first force, that is 600 Newton here. Okay, the formula for to find out the x component for the given force which is making an angle of 35 degree with respect to the horizontal is, that is F, that F is equals to 600 cos 35 degree. Okay, so and the answer for y component is 600 sine 35 degree. Okay, so these are my x component and then y component. Answer is 491.5. So here y component is 424.26. Coming to 500 Newton, the angle made by the force F2 with respect to the horizontal is 36.86. Let me go and write the formula here, that is 500 cos 36.86 and then y component is 500 sine 36.86. So these are my x component and then y component. The answer for the x component is 400 Newton and the next one is 299.93. So this is my 500 Newton force. the resolution of 500 Newton force. Coming to the third force, that is 800 Newton. Let me write the formula for x component and then y component, that is 500. Now here the angle is made with respect to the vertical axis. The angle is made with respect to the vertical axis. What is the value of theta? Theta is 26.56 degree with respect to force F3. Okay, now here the angle theta is made with respect to the vertical axis. If the angle is made with respect to vertical axis, the formula for x component would be F sine theta. So my theta is 26.56 degree. So similarly, for my y component, it is 800 cos 26.56 degree. So the answer for x component would be 357.7, and then y component would be 715.57 Newton. So don't forget to write the unit of all the forces, that is Newton, Newton, and then Newton here. Okay, so this is how the resolution of the given force system is done. What we have to do is, first we have to identify what are the angles made by each force. Then we have to prepare a table. So my first column would be force, second column would be x component, and the third column would be y component then. And then we have to make sure what is the angle made by each for, whether it is with respect to the horizontal or with respect to the vertical. If it is making an angle with respect to the horizontal axis, the formula is f cos theta and then f sin theta. If it is making an angle with respect to the vertical axis, the formula for x component and y component would be f sin theta and then f cos theta. Okay, this completes. The solution for the previous problem is displayed on the screen. There's a small mistake while calculating the x component and y component of force F1. That is, y component, it is 600 sine 35 degrees. The answer is 344.15 Newton. Instead of this, I had written 424.26. Kindly make a correction over that. And the second problem is, resolve the forces P along X, Y axis. Okay, so the axis is missing here. This is my X axis and then this is my Y axis. There is a force P is given, that is the value of P is 4 kilonewton. The angle made by force P with respect to the horizontal, it is 45 degrees. Okay, so let me solve this problem once again. Fx equal to f cos theta and then fy equal to f sin theta. The why we are using this formula is, the angle theta is made with respect to the horizontal. Now what is the value of force? F is 4 kilonewton. What is the angle made by force with respect to horizontal? It is 45 degree. And then what is the angle made by the force again with respect to horizontal for the y component is again is equals to 4 sine 45 degree. Okay, so sine 45 into 4, and then for x component it is cos 45 into 4. So the answer for x component is 2.82 Newton, and then for y component, that is Fy, again it is 2.82 Newton. Okay, so we can recall one statement earlier which we discussed in the previous session, that is, if the force is making an angle 45 degree with respect to the horizontal axis, both Fx and Fy will be equal. That is, if force P is making an angle of 45 degree, if theta is 45 degrees, then Fx equal to Fy. You can observe the same condition here. In the given problem, the force B is making an angle of 45 degree with respect to the horizontal. The answer for Fx and Fy is 2.82 Newton. Both values are same. And the next problem is resolve the forces for the force given is Q equal to 2 kilonewton along XY axis. So again, this is my x-axis, this is my y-axis. So you can see here this force Q equal to 2 kilonewton falls in third quadrant. If it is falling in third quadrant, Fx will be negative and then Fy will also be negative. This we have already discussed in the previous session. So the answer for Fx and Fy will be negative. So coming to resolution of the force Q, what I'll do? So Fx equal to Q cos theta. So as the angle 60 degree is made with respect to the horizontal axis. Similarly, we can go for Fy equal to Q sine theta. Okay, so the value for Q here is 2 and the value for theta is 60 degrees. Okay, so cos 60 degree into 2, the answer would be 1 kilo Newton. Okay, so similarly for y component, the value of Q is 2 and sine 60. So the answer for this would be 2 into sine 60. You'll get the answer as 1.73. So as we told in the beginning of this problem, Fx will be minus and then Fy will also be minus. That is minus 1 kilo Newton, or it can also be written as 1 kilo Newton. We have to mention the direction of the force. This is acting towards the left side. That's why it is taken as minus this. Similarly, for the y component, the answer is minus 1.73 kilo Newton. So, or it can also be written as 1.73. We have to mention the direction of force, that is towards downward direction. This we have to always remember to write the direction and then to write the unit of the given force. Suppose if it is kilonewton, we have to write kilonewton, or else if whatever is given in the question, that is either Newton or kilonewton. But we have to make sure we have to write the proper direction and then the unit of the given force. So let me go to the next problem, that is resolve the given force along xy axis and then x dash y dash axis. So we can see in the figure there it is an inclined plane and then the force is acting at 40 degree with respect to the x axis. Okay, so here we have to do twice. We have to resolve this problem twice. First with respect to xy axis, next with respect to x dash y dash axis. First let me go for xy axis here. Okay, let me solve the problem for xy axis. Now with respect to the xy axis, which is my xy axis? This is my x-axis and then this is my y-axis. Both are perpendicular to each other. Now we can see there is a force of 200 Newton which is making an angle of 40 degree with respect to the x-axis. Now for this one we can easily resolve the forces there. that is fx equal to f cos theta and then fy equal to f sin theta. So the value of f is 200 Newton and the value of theta is 40 degrees. So let me write the equation for fx. It is 200 into cos 40 degree. So you'll get the answer as 153.20 Newton, or we can also write it as 153.20. You can see the force is falling in first quadrant. That means my x component will be positive. I'll write the direction towards the right hand side. Okay, so this is my x components. Let me go for the y component. The formula for y component is fy equal to f sine theta. My sine theta is sine 40. Okay, so let me write 200 sine 40 degrees. So the answer for this would be 128.55 Newton. So again it is falling in first quadrant. The my force will be y component will be acting upwards. So this is my resolution of the given force, that is 200 Newton with respect to x and y axis. So the answer you can see which is displayed on the screen. My fx answer is 153.20 and then my fy answer is 128.55 Newton over there. So we'll go for x dash y dash axis now. Now let me find out the answer with respect to x dash axis and then y dash axis. Okay, so now here we can see F equal to 200 Newton. It is making an angle with respect to horizontal axis, that is x axis. Now we have to find out the answer, that is x component and y component with respect to x dash axis and then y dash axis here. Okay, so now we have to make sure that F, that is theta, should be between force and then x dash axis. Now we don't know what is this angle here. Suppose if we know this angle, we can add this, that is 40 degrees plus theta degree, and then we can easily find out what is the angle made by force F with respect to the x dash axis there. Now you can see this force is on the inclined plane. This inclined plane is making an angle of 30 degrees with respect to the horizontal. If this is 30 degree, so this also will be equal to 30 degree there. Now if this is 30, if this is 40, the angle made by the force 200 Newton with respect to the x dash axis is 70 degrees. Now we can easily find out the x component and then y component. So my x component formula is fx equal to f cos theta and then fy equal to f sin theta. So the value of my f is 200 Newton and then into cos theta, cos 70 degree. So we are going to get the answer for this as 68.0404 Newton there. Okay, so as this is falling in the first quadrants, it will be positive. That means we can write the sign convention like this. Similarly, we can find out the value of Fy, that is F sine theta. F is 200 into sine 70 degrees there. So we'll get the answer for this as 187.93. So as it is in first quadrant, the value Fy will be moving upward there. So this is how we can find out the answer for Fx and Fy if the force is making an angle with respect to x dash and y dash axis. So in the previous step, that is in the previous slide, we solved for the problem that is for the force which is making an angle 40 degree with respect to x and y axis. Now we did with respect to x dash and. So the next problem is resolve the force F equal to 400 kilonewton as shown in figure there. So this is my F, this is my vertical component, and then this is my horizontal component there. Okay, so the angle made by the force F is not given in this question, but the slope made by the force with respect to horizontal is given there. So there are two methods as we discussed earlier. There are two methods, that is without finding out the angle theta and then with finding out the angle theta. So let me go to this problem without finding out the angle theta there. Suppose if this is 3, this is 5, and then this would be, that is by applying a Pythagoras theorem we can easily find out the answer for the hypotenuse there, that is square root of 3 square plus 5 square, you'll be getting as 5.83 here. Okay, now we can find out the answer for cos theta. Cos theta is equals to, so adjacent upon hypotenuse. Now which is my angle theta? So let me consider this as angle theta. So we'll apply the trigonometric formula, that is cos theta equal to adjacent. Adjacent is my 3 by 5, hypotenuse 5.83. Similarly we can go for sin theta. Sin theta is opposite. Opposite is 5 by 5.83. So we'll get the answer for cos theta and sin theta. So we'll not simplify right now. We'll substitute this cos theta and sin theta in the x component and y component formula there. So let me write the formula for fx equal to f cos theta, and let me substitute the value of f. F is 400 into cos theta. Cos theta is 3 by 5.83. So we are going to get the answer for this as 205.83 kilo Newton. You can see it is acting in first quadrant. Let me write the direction like this, towards the right direction. So let me go to the second component, that is y component, that is fy equal to f sine theta here. Okay, so fy equal to 400 into sine theta. Sine theta is 5 by 5.83. So once we substitute this and find out the answer, we are going to get the answer as 343.05 kilo Newton, and then the direction would be upward. This is how the resolution of force can be done without finding out the angle theta here. Now the same problem can be done by finding out the angle theta there. Okay, so let me find out the angle theta there. So this is my theta. So you can find out the angle theta by using the formula, that is tan theta is equals to tan inverse of opposite upon adjacent. Which is my opposite? This is my phi. Which is my opposite, sorry, adjacent? It is 3. Suppose if we substitute tan inverse of 5 by 3, we are going to get the answer as 59.03 degrees there. Okay, now we found out the answer for theta. So we can substitute this theta in x component and y component equation. Let me go for the first one, that is fx equal to f cos theta. Value of f is 400, and what value of cos theta is cos 59.03 there. Okay, so the answer for this would be 205.73 7 or 8. So this is kilonewton. So let me write the direction like this. Similarly, we can go for y component. Fy equal to f sine theta. We'll substitute the answer here. 400 into sine 59.03. So we'll get the answer for this as 343.05 kilonewton. So let me write the direction like this. So this is how we can find out the answer for x component and y component after finding out the angle theta. In the previous slide we did without finding out the angle theta. Now in this slide we found out the angle for theta and then we solved the problem. The next problem is resolve the forces shown in the figure into horizontal and vertical components if F1 equal to 50 Newton and F2 equal to 100 Newton. You can see in this figure there are two forces which are acting in the first quadrant and in the third quadrant. So we have to make sure what are the signs of x component and y component for the individual forces here. Now we can observe by seeing the figure that the angle made by the force 50 Newton with respect to horizontal is not given, but the slope made by the force is given over there. You can see theta 1 is represented, and then for 100 Newton you can see theta 2 is also represented in the given figure. Again, similarly for the 100 Newton force, you can see there is no angle given there. Again, the slope of the given force is given there. You can see from the figure that slope made by the line 50 Newton, it is given as like opposite side is 1 and then adjacent side is 1. We can solve this problem by two methods. That is, in first method, we don't have to find out the angle theta. We can directly substitute the answer for cos theta by using this figure details, and then we can find out the answer for fx and then fy values there. Similarly, in the second method, we can find out the angle theta made by 50 Newton and then 100 Newton. Then we can find out the answer for fx and then fy. Let me solve this given problem without finding out the angle theta there. Okay, so for that, I will prepare a table there, just like I did for the previous problem there. That is, my first column would be force and the second column would be x component and the third column would be y component. So why I'm doing this one way, it will be easy for me to find out all the answers in a single table there. So let me write my first force as 50 Newton there. So what is the formula for x component? It is f cos theta. So let me write what is the answer for cos theta and then sin theta. Cos theta is adjacent upon hypotenuse. My adjacent is 1. My hypotenuse would be root 2 there. Okay. So this is my root 2. So same thing I'll substitute here. That is 500 into 1 divided by root 2. You are going to get the answer as 35.55 Newton. Sorry, 35.35 Newton. This is my x component. Similarly, we can go for y component. That is 50 into sine theta. So let me find out the answer for sine theta. Sine theta is equals to adjacent, sorry, opposite upon hypotenuse. Again, my answer is 1 by root 2. Okay, so 500 into 1 by root 2. So is equals to 35.35 Newton. By seeing the answers, we can make out that 50 Newton is making an angle of 45 degree with respect to the horizontal. Why? Because both my x component and then y component are same. That's if both the components are same, that means the given force is making an angle of 45 degree with respect to the horizontal. Okay, so this completes my resolution of the first force, that is 50 Newton. Let me go for the second one, that is 100 Newton. Here in this case, it is given as slope, that is theta 2 is not given, but the slope is given this. So in that case, what we have to do is we have to find out what is my cos theta and then what is my sin theta. Cos theta is given by, you can see, theta 2 is making an angle with respect to the horizontal. So my theta 2 would be cos theta is equals to adjacent. Adjacent is my root 3 divided by hypotenuse. Hypotenuse would be 2. So that is 1 square, square root of 1 square plus root 3 square. So it will be 4, square root of 4, square root of 4 would be 2 there. That is cos theta equal to root 3 by 2. Similarly, we can go for sin theta. Sin theta equal to opposite. That is opposite is 1 and hypotenuse is 2 there. It is 1 by 2. So let me write the force in the given table here. That is 100 Newton. My x component would be 100 into cos theta. Cos theta is root 3 divided by 2. Suppose if you substitute 100 into root 3 divided by 2, you are going to get the answer as 86.60 Newton. And then for y components, the answer would be 100 into sin theta. Sin theta is 1 by 2. You'll get the answer for this as 50 Newton there. So we didn't mention the sign for both the cases. Let me write the sign for the first one, that is 50 Newton there. So you can see that 50 Newton is falling in first quadrant. That means both my x component and y component would be positive. So I can write like this. So this is acting towards the right side and then y component is acting towards the upward side. So coming to 100 Newton force. This 100 Newton force is falling in third quadrant there. That means my Fx component would be negative and Fy component will also be negative. Let me write the sign convention for this. This is my x component, that is which is acting towards the left side, and then this is my y component which is acting downwards, or else this can also be written as minus 86.60 Newton, and y component can also be written as minus 50 Newton. This is how the resolution of the given forces can be done without finding. So we'll go to the next problem, that is resolve the self weight of the block into x and y component. That is the weight of the block is 50 kilo Newton there. Okay, so you can see the block is not resting on the horizontal plane, but it is resting on the inclined plane. So in order to solve this, let me draw the axis of reference for this block with respect to the inclined plane only. Let me draw the axis like this with respect to the block. Okay, so you can see the weight of the block is falling in which quadrant? Third quadrant over there. Okay, so we have to find out what is the angle made by the weight of the block with respect to horizontal or vertical over there. So now what I did in order to find out the angle theta there, so let me take this angle as theta here. Okay, so I'll extend this reference axis line till the horizontal plane. If I extend till horizontal plane, so this constitutes a triangle, that is, let me write it as O, A and then B. So we'll get the triangle here, that is this triangle. We'll get this triangle here. Okay, let me take this as my theta here, and then this is my 90-degree force. Now we have to find out the angle theta here. in this given case, the inclined plane is making an angle of 30 degrees there. Okay, so before going to that, so let me take another triangle here. Okay, so this is my C point and then this is my D point. So let me take one more triangle here. Okay, so I'll just draw like this. This is my one more triangle, that is D, C and then B. So this is my 90 degrees. Okay, so we have to find out the angle made by DB and then CB. Okay, so this is theta 1. Okay, this is my 30 degree. Okay, so the sum of all the angles of a triangle should be equal to 180 degrees there. Now we don't know theta 1, we can find out by applying this formula there, that is 180 minus 30. You are going to get the answer for, sorry, 180. So you'll get the answer for theta 1 as theta 1 is equals to 180 minus 90 minus 30. So you're going to get the answer for theta 1 as 60 degrees here. So you got the answer for theta 1 as 60 degrees. So let me write here as 60 degrees. So we'll write the same angle with respect to this triangle also, that is triangle OA and then B here. Okay, suppose if this is 90 degree, if this is 60 degrees, the answer would for theta would be 30 degrees here. That is my theta is equals to 30 degrees. This is how the weight, that is angle made by the weight of the block, is found out. Okay, so let me resolve this weight of the block here. Okay, Fx equal to W cos theta and then Fy equal to W sin theta only if the angle made by the weight of the block is with respect to the horizontal axis. Now the angle theta is made with respect to the vertical axis. Now the formula will change for x component and y component. The formula would be Fx equal to W sin theta and then Fy is equals to W cos theta. So the value of W would be 50 into sine, what is the angle theta? It is 30 degrees there. Okay, so the answer for this would be 50 into sine 30. You are going to get the answer as 25 kilonewton there. Okay, you can see the force Fx is falling, F is falling in third quadrant. The sign for Fx would be minus 25 kilonewton there, or 25 kilonewton. You have to mention the direction of force like this. Okay, so let me go for the y component. Fy equal to W cos theta. W is 50 into cos 30 degrees over there. Okay, so 50 into cos 30, you are going to get the answer as 43.30 kilonewton, or else it can also be written as minus 43.3 kilonewton, or else it can also be written as 43.3 kilonewton. We have to mention the direction here, that is downward direction. Okay, this is how the resolution of self weight of the block is done. So the next problem is resolve the forces shown in figure into horizontal and vertical component over there. Okay, you can see there is a block which is resting on the inclined plane. That inclined plane is making an angle of 20 degrees with respect to the horizontal there. Okay, so this problem is very simple. You can see the force of 235 Newton is making an angle of 60 degree with respect to the horizontal there. Okay, so all these dimensions, all these angles are given just to confuse you. The question is very simple. Resolve the forces shown in figure into horizontal and vertical component. You don't have to worry about this inclined plane and all. Suppose if this angle is not given, then you would have thought about this 22 degrees, but now the force 235 newton is making an angle of 60 degrees with respect to the horizontal. Then you don't have to worry about anything. Directly you can substitute in the x component and y component formulas over there. Okay, so let me write the formula for the x component. X component is fx equal to f cos theta there. My value of f is 235 newton, and the value of theta is 60 degrees there. Okay, so these two values I'll substitute in this equation. The value of f is 235 into cos 60 degrees. Okay, so cos 60 into 235, you are going to get the answer as 117.5 Newton there. Okay, so you can see the force 235 Newton is falling in second quadrant. That means my Fx value would be minus 117.5 Newton there, or it can also be written as 117.5 Newton. You have to mention the direction of x component. Okay, so let me go for y component here. Fy is equals to f sine theta. So the value of f is 235 and the value of the sine theta is sine 60 degrees. Suppose if you substitute this one, you'll get the answer as 203.51 Newton there. Okay, this force is falling in second quadrant. That means my Fy component will be positive. This can also be written as 203.51 Newton. You have to mention the direction of force, that is upward direction. This is how the resolution of the force is done for the given problem. The next problem is resolve the forces shown in the figure into horizontal and vertical components. So you can see the figure which is displayed on the screen. There are n number of forces. So what is the first step when such problem is given? So we have to identify how many number of forces are given. That is first thing. And then we have to see what are the reference axes. That is with respect to what axis the angles are made here. Okay, so let me identify the forces one by one. Okay, the numbers for the forces is not given. So let us find out the numbers, or let us write the numbers for the given forces here. Okay, let me start with this first force, that is with 10 Newton force. Let me take this one as F1. You can see there is a force of 25 Newton which is acting exactly along the vertical axis, that is along the north direction. Let me take this one as F2. Okay, so let me come to this force, that is 30 Newton. Let me take this one as F3 force, and then we have one more force of 20 Newton. Let us take it as F4 here. Okay, and then you can see there is one more force of 15 Newton which is acting exactly along the horizontal axis. This will take it as F5 there. Okay, now we can observe there are totally 5 forces in the given problem. Now let us find out what are the angles made by these individual 5 forces. Okay, so we'll go to the first force, that is F1. F1 is making an angle of 45 degree with respect to the horizontal axis. Coming to F2, F2 of 25 Newton is making an angle of 90 degree with respect to the horizontal there. So that means if you are measuring with respect to the horizontal, this is the angle made by F2 with respect to the horizontal. Okay, so let us take this one as 90 degree for F2 force there. Coming to force F3, it is making an angle of 60 degrees with respect to the horizontal. Coming to force F4, 20 Newton is making an angle of 30 degree with respect to the vertical axis. Just make sure here this force is making an angle of 30 degrees with respect to the vertical axis. We have already discussed in the previous problem that if the force is making an angle with respect to the vertical axis, the formula for x component and y component would be f sine theta and f cos theta. This we have to remember carefully. Let us go to the next force, that is Fy. Fy is 15 Newton. 15 Newton is making an angle of 0 degrees with respect to the horizontal there. You can see that 15 Newton is acting exactly along the horizontal axis. That means there is no angle between force and then the horizontal axis. That means there is 0 degree for 15 Newton. So in order to solve this problem, let us prepare a table there. So my first column would be force and the second column would be x component and then third column would be y component there. So we have already named the force here, that is F1 equal to 10 Newton, F2 equal to 25 Newton, F3 equal to 30 Newton. Similarly, F4 equal to 20 Newton, F5 is equals to 15 Newton. We'll find out the x component and y component of all these forces over there. Okay, so let us go for the force F1 equal to 10 Newton there. The formula for the x component would be F cos theta, that is F equal to 10 into cos 45 degree. We are going to get the answer as 7.07 Newton. Okay, so let us write the sign for this. You can see F1 is falling in first quadrant. That means x component and y component will be positive. That is plus 7.07 Newton there. Okay, let us go for the second, that is y component. F into sine 45. Okay, sine 45. You'll get the answer as 7.07 Newton there. Okay, so again it is falling in first quadrant. That means the answer would be plus 7.7007 Newton. We can recall the condition here. That is, if the force is making an angle of 45 degree with respect to the horizontal axis, we can see that the value of Fx will be equal to value of Fy there. The same thing we have observed in this given case there. We'll go for the second one, that is F2 equal to 25 Newton. We'll just write the formula for this, that is 25 into cos 90 degrees. Okay, so cos 90 into 25 would be 0. You can see cos 90 is 0 there, 25 into 0 would be 0 there. So let us go to the y component, that is 25 into sine 90 there. We'll get the answer as 25 Newton there. You can see this F2 is acting upwards. That means you can write it as 25 Newton upward direction or else plus 25 Newton. By seeing this results, we can also recall the condition that if force is acting along the y component, that is Fx will be equal to 0 there. Same thing we have observed here. And then Fy will be equal to the force given there. You can see Fy is equal to 25 and the given force is also 25. We can recall that condition there. Let us move to the third force there, that is 30 Newton. So we'll apply the formula here, that is 30 into cos 60 degrees. Okay, so you'll get the answer as 15 Newton there. Okay, so you can see this force is falling in third quadrant. That means both Fx and Fy will be negative there. That's why I've written as minus 15 Newton there. Let us go to the y component, that is 30 into sine 60 degrees there. Okay, 30 into sine 60. You'll get the answer as 25.98 Newton there. Okay, I'll write it as minus 25.98 Newton there. Okay, so this is how third force is resolved there. Fine. So let us go to the fourth force here. Okay, 20 into, you can see the angle 30 degrees is with respect to the vertical axis. In that case, the formula will change for Fx there. That is 20 into sine 30 degrees. You'll get the answer for this as 20 into sine 30. You'll get the answer as 10 Newton. You can observe that F4 is falling under fourth quadrant. In fourth quadrant, Fx is positive and Fy is negative there. So what I have to write here for fourth quadrant for Fx, it is plus 10 Newton there. So we'll go for the y component, that is 20 into cos 30 degrees there. Okay, so 20 into cos 30, you are going to get the answer as 17.32 Newton there. And then this value would be minus y because the force is falling in fourth quadrant. In fourth quadrant, y component will be negative there. Okay, so next one is Fy force. So we'll write the equation for x component and then y component there. Okay, so Fy is equals to 15 Newton. The formula is, you can see there 15 Newton is making an angle of 0 degree with respect to horizontal. That is 15 Newton is acting along the horizontal axis. That means there is no angle between 15 Newton and then the horizontal axis. So we'll substitute like 15 into cos 0 degrees. So you'll get the answer as 15 Newton there. You can see the force is acting towards the right side. That means it will be plus 15 Newton there. When it comes to the y component, we'll write the formula for this as 15 into sine 0. Okay, sine 0 is 0. You'll get the answer as 0. By seeing this results, we can recall one more condition, that if the force is acting along the horizontal axis, my Fy component will be equal to 0 and then Fx component will be equal to the given force. My given force is 15 Newton and my Fx component is also 15 Newton and Fy component is 0 Newton then. Okay, this is how the given problem can be solved. Okay, I'll just recall once again what we have to give, what we have to do when such problem is given. When such problem is given, we have to identify the number of forces. That is first thing, how many number of forces are given. We have to carefully observe whether the forces are acting exactly along the horizontal axis or exactly along the vertical axis. Then we have to go for finding out the angle made by each force. And then we have to identify in which quadrant the forces are acting, whether the forces are acting in first quadrant, second quadrant, third quadrant, or fourth quadrant. If they're acting in different quadrant, we have to identify the sign of each component, that is Fx and then Fy. Okay, so this is how we have to do the resolution of forces for the given problem. If we prepare a table, it will be easy so that your writing effort will be reduced and then you can reduce the time also.
Thank you.